Alright, we are live. We have a handful of questions to go through in lesson 4. These are all going to be found in chapter 3. And everybody's here, so let's get started. Get this over with. In the United States, how are conductors sized? They are sized by American wire gauge. You all have that one. Good job. Calculate resistance of wire with a diameter of 16. Okay, so math time. So let's open up Paint. So, first off, the formula that we're going to use for this is going to be R. Let's change our pin size. R equals K times L over area in circular mils. K is the resistance value, which I believe was given in the question. L is the length of the wire. Then area in circular mils is the area in circular mils. So let's get some numbers. We've got 10.4K. It has a diameter of 16.2 mils. That is not circular mils. I would argue that this question should be later in the lesson, but the quiz is shuffled, so and a length of 15,840 feet. So let's move some of these numbers. All right, so 10.4 is K. Let's do R equals 10.4 is K. L is 15,840. $15,840. I didn't like that. Let's do. Yep. That's a much better line. No, I'm not a perfectionist. You're a perfectionist. All right. So, area in circular mils. So, there's a few things we need to cover before we get into what the formula is, but I'll put that up there. Is the diameter diameter in mils squared. So the area in circular mils is the diameter in mils squared. A mil is an inch times 1,000. A mil is 1,000th of an inch. They measure plastic in mils, like the thickness of plastic. So if you're like trying to buy yard bags, if you look, or like drop cloths, so if you're painting so you don't get paint everywhere, you can look and you'll have like 3 mil and 6 mil as options. The 6 mil is going to be twice as thick as the 3 mil. And that is a milli-inch. So, you have your mils, which is inches times 1,000. So, if you had, for example, a 1/2 inch wire, that would be 500 mils. Because 1/2 inch is 0.5 inches. Then you move the decimal 3 times to get to 500 mils. But they gave us the number of mils, so we don't need to worry about that one right this second. So, it was 16.2? 16.2, yes, it is 16.2. So you've got 16.2 squared is equal to our area in circular mils. So let's pull up. I should make a button on my keyboard for calculator. Oh, that's not it. And there's a square button. 262.44. All right. So let's do the math. 10.4 times 15,840. And then all that's divided by 262.44. 2.4. What did I do wrong? Okay, 16.2 mils. I have fucked up somewhere. 10.4 times 15. So that's going to be... oh, did I hit enter twice? I hit enter twice. So if you see right here is the answer. So 628 ohms. Yeah, okay. I played myself. Alright. The cross-sectional area of American conductors is expressed in units called circular mils, is how we measure that. Explain how to calculate the approximate cross-sectional area of a conductor in circular mils. So, that is what we covered on our thing that's right here. If you have the inches, you multiply it by 1,000, then square it, and that will give you your area in circular mils. On page, I want to say 73, 74, or 63 or 64. Uh, 73. Page 73 is is chapter 9, table 8 in your code book. They have a copy of it on page 73 in your DC, get the glare off, DC theory book. And you can, on that page, it will give you like approximate diameters of the different wire sizes and all sorts of information about the different wires. Okay, next question. Calculate the resistance of a piece of aluminum wire with a diameter of 100 mils and a length of 2 miles. So, and I just remember this from yesterday, whenever I did this. Aluminum has a K value of 17.7. That is on page 74. So the very next page from what I just told you to look at has the K values for all the different wires. The part where it's at 68 degrees Fahrenheit is because the K value for a material changes as the temperature changes. But 68 is like the baseline for this. So we're going to, that chart is what we're going to use, basically. We're not going to get that far into the math where I make you work out the K value at different temperatures. Okay. 100 mils. So that's 10,000 circular mils, right? Because 100 squared, I don't know what's up with this calculator. You see that? Is 10,000. So, let's just plug it. Let's write down our formula. So, R equals 17.7 times, so let's do that math because I don't feel like doing it in my head, times 2. 2 miles is 10,560. $10,560. I'm very clearly sitting at an angle to my drawing pad, so everything keeps going up as I write. And then, what did we, 10,000. Alright, so let's plug this into our calculator. I'll move it there, and I'll just use the, so 17.7 times 10,560 divided by 10,000, 18.69. Do I have an 18.69? Round the final answer to 2 decimal places. So 18.69. Let's see who the winner is. Jeremy Bivens. Also Cody Haynes. And Cody Haynes takes also the wrong answer. Hey, I don't, oh, there he is. Okay. 16.83, Stephen. Just get out of here with that. Oh, that's weird. I'm getting a lot of feedback in my headphones. Don't know what that came from. Was the approximate gauge of a wire with a diameter of about 100 mils. So you're going to look on Chapter 9, Table 8. And we already determined that it's about 10,000. And 10,000 circular mils is the easiest to remember because it's number 10. But look on Chapter 9, Table 8 because this is the first time y'all are seeing that information. Chapter 9, Table 8 is at the back of your code book. Okay, so the resistance of a specified length of wire is directly proportional to its resistance, specific resistance, or K value, also known as resistivity. Every material has a specific resistance. So looking at the formula, the bigger the K value is, the more resistance there is, and the bigger the area in circular mils is, the smaller the resistance is, because you're dividing by the area in circular mils. And then specific resistance is also called blank, and is abbreviated with the capital letter K or the Greek letter, that's a P. Did I copy paste? I think I copy pasted that letter. Rho is what it's named. And it's resistivity. We already covered what that is. Resistivity is, well, I'll go a little bit more in depth. Resistivity is the resistance of a piece of a material that is 1 mil thick and 1 foot long. So it's got everything like kind of zeroed out, all the variables zeroed out. And then for every foot longer it is, you multiply the resistance by that. Then for every circular mill bigger it is, you divide the resistance by that. And that's how that formula works. All right. Let's call that one done. And I will give you guys lesson 5. Of note, we will not be doing lesson... I'm not seeing lesson 5. I know it's here. I accidentally gave it yet. There it is. All right. We will not be doing lesson 8 today. We're going to go through what we've got, and then we will cover lesson 8 at a later time. All right. Oh, don't end that. I want to end the stream. All right, you guys. There will not be a test over all of these at the end of the day. I guess now's as good a time as any since I got 8 people watching. The way grading is going to be done for this time period is that there won't be grades, basically. Whenever we come back, we will take probably like one test that covers everything, and we'll review all of it. I mean, we're only covering one subject right now, and that's DC theory, and we're going to go through the different levels of DC theory. So it won't be like that wide-ranging of a test. Like the second years have like all sorts of crazy stuff. Look at Tanner go. He doesn't know we're watching. All right. So I hope that answered your question. We will take a test when we come back, and your grade will be based on that. We might take a bunch of tests, but we'll see.